Imagine solving a complex problem not in one step, but breaking it into smaller chunks or smaller tasks that can run independently and parallelly to solve the complete problem. So, this is exactly what the current architecture will be doing through DAG, which is directed acyclic graph. So, a DAG is simply a flow of steps connected in one direction like a flow workflow where each step depends on the previous one, but there are no loops. So once a step is completed, we move forward and we don't move backward. So in this architecture, when a user query comes or user asks a question, the system doesn't answer it directly. So as a step one, we have a planner agent, right, which analyzes the query and breaks it into a smaller task. For example, research, summarization, comparison, computation, and so on. So think of planner as a blueprint agent which will be represented as a DAG. Then the second step is the parallel execution where we have the power of the design where independent tasks like multiple research steps can be triggered at the same time in parallel instead of sequential approach. This significantly speeds up the process and makes the system more scalable. Then step 3, we have the dynamic graph growth where each task completes the system can dynamically add a new steps. For example, after research it may add a summarization step or so on. Then we step 4, we have a quality check with a critic skill. To ensure the accuracy, certain steps automatically trigger the critic agent. So if it is correct, if the output is correct, then the flow continues, and if it fails, the system intelligently replans and fixes the issue. So it behaves in a self correction mode. Then we have the execution and tool usage where we have different LLM calls through the gateway, tools like web search, comparison, and so on. And we have a running secure sandbox. And this all happens seamlessly as part of the DAG execution. Then we have the all the outputs are combined by the formatter agent and it generates a clean user friendly response. So and all these are being governed through the skills dispatch which are nothing but the prompt files, right? And these prompt files are being rendered via LLM and using the MCP tools it is trying to solve each and every user request. So the beauty of this architecture is that it gives us three important things. One is a parallelism, independent work happening simultaneously giving us 2 to 3 times of the speed up. It gives us resilience wherein if a failures gets classified and covered automatically, and auditability. Every note's exact prompt and output is saved, so we can replay the any session step by step. Let's see these classifications through an example. So let's say if I have a very basic query, it will just execute a planner and a formatter, and it will track down the speed, like how much time it took to execute a specific agent, and then it will give me the final answer. But if we have a little complex query where we are passing a URL and getting some information from it, again it is solving this problem, and we are getting the output. Now if we have a query where we have multiple run needs to be done, so let's say comparing the population of multiple cities, right? So if here you could see that multiple research are executed and they executed parallel. It's not that once researcher one is completed then only two is invoked. They are with a time lag, they all are invoked parallelly, and we are getting almost 2.5 times of the parallel speed outcome. And even if we have some failure, right, if the location doesn't exist and it is failed, then also the failure is being handled properly and captured in the final outcome. If anything breaks during the execution, right, then also we can resume based on the session ID. So it's not that once it is break on the researcher part, once it is resumed, it is actually starting from where it ended in the previous iteration. Now let's look at some parallel queries, right? And here you could see that we are getting almost two times of the parallelism, where the researchers are being triggered with a little lag. Then if I looking at some critic based evaluation, that if I put a very strong guardrail, that until unless those guardrails are met, my task is not completed, the critic failure is being observed, right? And it is auto resumed until the critic makes it pass and shows the final output. So this whole architecture help us in form of a growing graph orchestrator, where the DAG basically starts with one node, expands dynamically as the AI plans and executes. They runs independently and most importantly in parallelism, in self-healing mode when things go wrong. So the graph itself is the agentic loop. Hope you liked the video. Thank you.